Yo, what is up, YouTube? It's your boy, once again counting down top 10 op research midterm questions, starting with number 10, number 2 on the fall 2020 midterm 3. Um, so, in this problem, we're dealing with transferring Asian investments into the US domestic market. Um, and so we are given the carrying capacity of each ARC or each currency exchange and the price per unit of those currency exchanges. And so the first part of the problem wants us to set it up and draw the network, which I've done here. So all the values you'll see are in thousands of dollars. So something like 2,000 is actually 2,000 or 2 million. Just keep that in mind. I'm going to be using the written values, but you can multiply by 1,000 in your head if you desire. So let's zoom out a little bit. For this problem, we have 3 supply nodes and 1 demand node, and then by extension 4 transshipment nodes. The 3 supply nodes are yen, rup, and rin, which are where our money is to start with, and our 1 demand node is US dollars, which is where our money ideally ends up. And so here we're looking for 16,880,000 or 16,800,000. You get the idea. And we have 9,600 yen, 1680 rup, and 5,600 rin. And here I can zoom in, but the carrying capacity and the price per unit are listed on all the ARCs for all the exchange rates. I will just pause for a second so you can get a kind of good look at that. My cat howling in the background. And part 2 of this problem wants us to solve it in IBM. And so here 2B, I used the code from AI session 8 as a starting point. Thanks, Keith, for creating our minimum flow network problem. And then here in the data, I edited his original file to reflect ours. And so we have 8 nodes. Like we said, 3 supply nodes, which are the positive values, and then 1 demand node, which is the negative value. And then we list all the ARCs out basically one by one from to the cost of per unit and the capacity of that ARC. So this is the code representation of what's going on here, basically. And we see that if we run this, it tells us the total flow cost is going to be $83,380,000. So that's $83,380, which means that we have that much less on the other end to invest. Presumably, this comes from already domestic capital, but then it subtracts our total money that we have. So that's important to note. We can check the exact flow here. And so we see that we're using yen to USD, yen to CAN, yen to euro, yen to pound, yen to peso, rup to USD, rup to CAN, rup to euro, rup to peso, rup to pound, and then once rin to USD, rin to euro, rin to pound, rin to peso. And then for our transshipment nodes, we're going from CAN to USD, we're going from euro to USD, pound to USD, and peso to USD. So the transshipment nodes we're using are peso, pound, euro, and the Canadian dollars. Cool. There's another look. Let's see if I can freeze it in a good spot. All right, there you go. We have our sensitivity range here if we wanted to. If we have a reduced cost. So then part 2C forbids transaction limits, which basically means that there are no carrying capacities restrictions on any of your ARCs. And so I formulated that problem similar to 2B. The only difference now is that all the capacities are infinity. Nothing else has changed. I use the same model from AI session. And so we run the 2C. And we get, now it only costs $67,480. And the flow pattern has changed. So now we use a significant amount of yen to pounds, and then basically straight from pounds to US dollars. And then we go from rup to Canadian dollars and rin to euros, and then we translate both of those back, basically just taking the most favorable exchange rates And let's keep an eye on this cost, 67.48, because in 2D, the ROOP transaction rate goes up by 500%, right? So the model's the same, but now I've multiplied all of the costs in the ROOP node exchange rate section by 6. So here is the original, and then here's where it is now. And we run it again, and we'll see the same networked flow, but now, so you see, hold up. So here's the same network flow where we're going from yen to pounds, ROOP to CAN, and RIN to euro. So that hasn't changed at all, but what has changed is our cost of doing business, which is now $92.68. So that's, kind of interesting, right? And finally, we have to talk about what things Jake might have missed, yeah? And so I mentioned that the currency exchange rates are fluctuating constantly, actually. And so Jake might have to consider like the daily exchange rate, or even like the exchange rate at that moment where he presses the go button, because they might not be exact reflection of what we have in the tables, and also might change the solution, depending on what the rate is that day. We also might want to consider more transshipment nodes than just these 4. It could be beneficial if there's a more favorable exchange rate we haven't considered yet. And finally, it might be outside the scope of the problem, but as a better U.S. domestic investment, bonds are safe but have low interest rate. And so if you want to take a little bit more risk, you could accrue more interest, which might be a better investment, make his boss happy with him. Yep, that's it for me. Thanks.